Hello everyone, a very warm welcome to this session. I am Amiraj and I welcome you to today's session. Hi to everybody. I am live in front of all of you. How are you all doing? I hope all of you are doing absolutely fine and amazing. All of you are staying very healthy in this lockdown period, and all of you are taking the preventive measures because we all know that during this pandemic period, we need to become the responsible citizens and take the preventive measures. Okay, stay home and stay safe. So, welcome to the very first session of CBSE 10 Physics chapter 12, that is electricity, and one of the chapter which has got so much of demand, and that's why I had to start this chapter. And I'm very excited to start with this chapter because this is something by which children are generally afraid of. Even I don't know why children are afraid. It's not that tough, but yeah, I would say that you need little bit of hard work to crack this chapter. So today, let me tell you what are the different topics that we'll be doing in this particular chapter. Now, first thing, there are certain important aspects. Like if I'm talking about electric current, so you should know the definitions because generally in board exams, children have practiced all the numericals, all the important questions, but if they're not thorough with the definitions, if they don't know what is the current, then how will it be helpful, isn't it? So you should be able to know the definition, okay, that what is electric current. Then we have potential difference, which is also known as voltage. Generally, people get confused. What is this potential difference? What are you talking about? So it is the voltage and electric potential. I will explain you today. Then we have Ohm's law along with resistance. Resistance is something which is very crucial in this chapter as per your CBSE 10 syllabus, because in resistance you will be having the factors affecting it. Then we'll be having resistivity, resistors in series and parallel. Then we'll be having heating effect of electric current and electric power. So it is a small chapter as compared to light is a very big chapter. Reflection and refraction, two aspects are there, but I would say that if we all are doing hard work, then we can easily crack any of the chapter. So do you all agree with this? Will you crack the chapter, the electricity chapter? Hello everyone, how are you all doing? Okay, so shall we begin with the chapter? Let's begin now without wasting even a single minute now. Now I wouldn't focus on the chats for the next 5 to 10 minutes because I want to explain you something very important. So please everyone pay attention over here. So we are doing electricity first part, the very first session till now. If I am talking about the CBSE 10 perspective, then we've had 2 sessions on live processes chapter, and if you have missed even a single session, go and watch from the playlist because live processes is a very important chapter from your biology point of view. Then we have done 1 chapter of geography, resources and development, first part. Second part will be coming soon after I think we finish electricity or live processes, or let's see. Okay, and now we are beginning with electricity, the first part of electricity today. And today the topic or the agenda that we'll be covering is electric charge and current. First we'll be understanding what is an electric charge and how is it related with the electric current. Let me change the color. Okay, then we'll be understanding the electric potential and the potential difference. What do you exactly mean by both these terms? I think in your school you must have studied this chapter, or those of you who have started with the light chapter, this will be a very new chapter for you. Okay, so be ready to crack this chapter along with me. Pay attention and start making your notes. Take care. So be ready to take it. So let's get started. Okay, hi Art Arena. Okay, so let's start with the chapter. First thing is the electric current that we are talking about. So generally, what do you mean by the electric current? Who is going to tell me? Yes. Tell me, what is electric current? Okay, now let me tell you the definition of electric current. the rate of flow of charge is termed as electric current. Electric current is nothing very new. Electric current is something which we've already studied. It is the rate of flow of charges. Now first thing, what are charges? You would ask that what do you mean by charges? So we all have read in chemistry about the electronic configuration of any element. So in the electronic configuration, you read that for an atom to be stable, it needs 8 electrons in its outermost shell. Correct? So let me repeat, please understand, in an atom, any element, it needs 8 electrons in its valence shell or the outermost shell. So we know that there are different shells, and in those shells we fill the electrons according to the 2n square rule. So in the first shell we are going to fill 2 electrons. Then in the second shell we are going to fill 8 electrons, maximum of 8 electrons, and here 18 electrons in the outermost shell, or it depends on the atomic number of that particular element. So what do we have to understand in this case? That in the first shell you have 2 electrons. Okay? In the second shell you have, suppose, 7 electrons. Then it means that particular element is not stable, because for stability an element needs 8 electrons in its outermost shell, and it is also known as the valence shell. So for getting 8 electrons in the outermost shell, the atom tries to make some chemical bonding. Okay, like either we can make you can say the bonding between different elements by gaining, okay, losing, 1 minute, and sharing the electrons. Okay, these 3 things are possible. Pay attention please. Either by gaining, by losing, or by sharing electrons. By doing this, any element can be very much stable and can complete the octet rule. What is the octet rule? I've already explained you. In 9th class you must have read that in an element the outermost shell should have 8 electrons. So whatever electrons they gain, they lose, or they share, it becomes their valency. Okay, so this valency gives us a charge. 1 second, yeah. So it gives us a charge. It gives the element a charge. Okay, if they gain, lose, or share an electron to complete the octet rule. Like for example, let's take an example. Let's see, if I have sodium and chlorine, I have 2 you can say elements. So if I talk about the configuration of sodium, it is 2, 8 and 1, because atomic number is 11, so the configuration will be 2, 8, 1. Now if I talk about chlorine, the configuration is 2, 8, 7. Okay, because the atomic number is 17, here the atomic number is 11. So this is the configuration of sodium and chlorine. Now sodium would become stable if it loses the electron, the 1 electron which is present in its outermost shell. And chlorine, which has 7 electrons in its outermost shell, will want 1 electron to complete its octet. So it will become 288 if it gains 1 electron, and if sodium loses 1 electron, then its configuration will become 28. Okay, so this thing you have to understand over here. So after they gain and lose, they share the chemical bond, and through this bond they obtain the charge. Now you know about protons and electrons very well, that the number of protons is the atomic number. Yes, the number of protons is the atomic number. So now concentrate over here. 1 minute, let me change the color. So if I'm talking about sodium, its atomic number is 11, correct? And if I talk about chlorine, its atomic number is 17. Here also I have told you when I taught you the electronic configuration. Yes, Menti quiz will be there. Do stay till the end. Everyone, Menti quiz, whoever is asking for the Menti quiz. Okay, so where were we? Yeah, so here we can know that according to this configuration, sodium has 11 you can say the protons, 11 protons, and chlorine has 17. Okay, now if sodium is going to lose 1 proton, sorry, one electron, sorry, and protons and electrons are equal in number, you know this also. So if sodium is going to lose one electron, -1, then it will be left with only 10 electrons and protons are 11. So now if you subtract both of them, you get +1. This is the valency and this is the charge. And same here with chlorine, if we add one electron, then 17 plus 1 becomes 18, correct? So here, now it is going to have 18 electrons in total, correct? So now the if I talk about the protons minus electrons, so 17 protons are there as we know, and now 18 electrons are there. So the charge is -1. The valency will be 1. Okay, valency is not going to be negative, but the charge is going to be negative. So this is something by which the charge, the electric charge is originated. We get the electric charge by this. I actually taught chemistry, if I am not wrong, instead of teaching physics, because this was very, very important from the science perspective, that how did we get this +1 charge. So now coming to the topic, coming to the physics topic now. Now are you able to understand rate of flow of charges? So these charges, when they get originated, they start flowing. Okay, because we know that protons cannot flow because they are inside the atom. But the electrons, they are outside the atom. They are in different shells. So sometimes it happens that they start flowing. And rate, we know that time is also going to increase. So they are going to flow. So we can say charge is also, sorry, the current is also the flow of charges per unit time. Okay, per unit time, the flow of charges is gonna be termed as your electric current. Like here in this wire, the charges will flow, okay, because of the electrons. Now I have taught you in depth what is the charge and how we got this. I hope my video is clear. Let me just check. Okay, so now we are moving ahead. Actually, now I am not going to focus on the charts because I think my net is going to be very, very slow otherwise. Okay, now something very, very important, that what is the expression for electric current? What is the formula? See, generally we denote electric current by I. Okay, by letter I. Then according to the definition, it is the rate of flow of charges. So charge is denoted by the letter Q, correct? And it is written rate. Whenever rate comes, you can write upon time, anything upon time in the formula form. So here rate of flow of charges, so charge upon time. This is your formula for the electric current. So if you are asked to find the electric current, then you will say it is Q upon T, or charge upon time. You will apply this formula. Now next thing that you should know about it is the SI unit of current. What is the SI unit of current? It is coulomb per second or ampere. Now how do you make the SI unit? Let me tell you over here that how would you make the SI unit. Now you know that the formula, according to the formula, we have that over here I is equals to Q upon T. Okay, I is equals to Q upon T. So I can say that I will be equals to, what is the SI unit of charge? Those of you who don't know, it is coulombs. Okay, coulombs. And what is the SI unit of time? It is seconds. Done. So according to the formula, your SI unit should be coulombs per second. But because a scientist was there, a physicist whose name was Andre Ampere, he contributed a lot in the field of electricity, and that's why to honor him we use the SI unit ampere for electricity, for electric current, and it is denoted by A. So short form is A. So if you want to write current, let's say 3 ampere current, I'll write like this. Clear? So 1 ampere is 1 coulomb upon 1 second. Sometimes in the board exams this question comes that define 1 ampere. Then what are you going to write? 1 ampere is equals to 1 coulomb upon 1 second. Clear? Or you can say 1 coulomb charge which flows in 1 second. That is 1 ampere. Now 1 ampere is the current which flows in a conductor when 1 coulomb of charge passes in 1 second or flows in 1 second. Is this much clear? With this we've completed the electric current. Let me open the chart once. Is this much clear? Just a second, give me a second. Okay. ठीक है. So now we are moving ahead. Now a question. Let's try to solve this question. Please be with me till the end, everybody, so that you can understand the concept of electricity. See, a current of 4.8 ampere flows in a conductor because we know that insulator does not allow electric current to pass through it. So conductor will only allow. The number of electrons that cross any section per second is what? Now, one thing I would like to tell you from here only, that let me tell you over here. Okay, that in one electron, have you wondered that how much charge is present or how much charge flows? Okay, so let me tell you, in one electron, 1.6 into 10 to the power minus 19 coulomb charge flows. Is it clear? So in one electron, this much charge, yes, this much charge flows. I hope this is clear, because this question is related to that only, so I do not want any problem. So the number of electrons that cross any section per second is this. Option A, 10 to the power 19. Option B, 10 into 10 to the power, 2 into 10 to the power 19. Option C, 3 into 10 to the power 19. Or option D, 3.3 into 10 to the power 19. Now everybody quickly solve and give me the answer in the chat box so that I can take your name. Yes, everyone, quickly tell me. Somebody saying D. Okay, so do you think that it is D? What are you thinking, guys? Let me know in the comment section. The question is in front of you. What are you thinking, guys? Let me know in the comment. Okay, so now your time's up and now I'll be solving it for you. Let me close the chart now. Yeah. So now it is given to us that the current which is flowing is the I is equals to 4.8 amperes. Clear? The current is given as 4.8 amperes flows in a conductor. So we have to find the number of electrons that cross any section per second. So per second means time is given to us 1 second. Okay, so I want to tell you one more formula with this. See, generally we say I is equals to Q upon T, charge upon time. But there is one more formula, that I is equals to NE upon T. Okay, this is the number of electrons. This is the electrons in this is actually one electron. Okay, number of electrons into one electron upon time, because this will only give us charge. So instead of charge Q, we can write NE upon T. So this is the formula. So if I is equals to NE upon T, now how are we going to solve it? Let me change my orientation so that I can just solve it. Okay, now pay attention. Okay, now concentrate over here. I is given to us 4.8. Okay, then if I am talking about the number, that is something which we don't know, and we know that generally the electron in, you can say, the charge of one electron is 1.6 into 10 to the power minus 19 coulomb upon time is given to you 1 second. Now if we want to calculate, let me change the color. Yes, so if you want to calculate N, then what will be your formula? I into T upon E. Okay, this is the basic mathematics that every one of you should be able to know. So now how are we gonna calculate? We will calculate by, you can say 4.8, that is your I, Let me write over here. 1 second. It is going to be n is equals to IT upon E. So I is this. Now what is the time? Time is 1 second, and electrons in the charge of one electron is 1.6 is into 10 to the power minus 19. So now you can see that 1.6 is a factor of 4.8. So how many times will it cut? 3 times. Clear? So n will be equals to 3 into 10 to the power 19. How? This is going to be 1. So actually it is going to be 3 upon 10 to the power minus 19. So if 3 into 10 to the power, let me do here. If 3 into 10 to the power 19, how we got this? Because 3 upon it would be 1 into 10 to the power minus 19. Now 1, leave it. If we'll send this 10 to the power minus 19 above, then the sign will be changed. So this negative will become positive. So we'll get that the number of electrons will be 3 into 10 to the power 19 if a current of 4.8 amperes is flowing in a conductor, okay, in 1 second. I hope it is clear. Now again, let me enlarge my camera. Okay, 1 second. What is happening here? Okay, now the answer is this. We are absolutely correct. It is 3 into 10 to the power 19. Now we've completed electric current and charge. Congratulations and hi guys. So now the next topic is electric potential and potential difference. So do you all know about this electric potential and potential difference? Okay, it is clear. Thank you so much that it is clear to you. Okay, so guys, what do you know? Is my camera visible? Okay, so guys, what do you know? Okay, now I'll be just beginning with it. 2 minutes. Okay, now we are starting with it. Okay, now we are starting with the next topic, that is your electric potential and potential difference. Okay, now what is the potential difference? Potential difference is the work done in moving a unit test charge from one point to another. What do you understand by this? Actually, potential difference, if we talk about this, it is the work done. Basically, in class 9th, you have read work and energy. So the work done, it is the work done to move a unit test charge. You can say, let's say 1 coulomb of charge. Okay, 1 coulomb of charge from moving from one point to the other. So because we know that the electrons are going to move. So the work done to move these electrons from one point to the other, from suppose A point to B point, that will be your potential difference. Okay, so you can see from here to here, from this point to from A point to B point. So that is going to be your potential difference. Electric potential difference, how are they similar? Like you can say, let's talk about any vegetable. Like we have potato, and we have a lot of potatoes and their difference. So isn't it going to be the same? Almost the same. All are potatoes only. So here also it is just the difference between this to this point. And electric potential is from infinity to a point. So from infinity to a point, that work done is electric potential. So they are almost the same. Nothing is much difficult in this. Is it clear that what is potential difference? Okay, so I am able to see that you all are saying yes, that it is super duper clear to you. Okay, now some important things that I want to tell you. See, potential difference is, now you have understood here, work done in moving a unit test charge. It means work done will be there. Okay, so work done is there, and upon charge, because we are moving our work done per unit charge. So work done upon charge. So what will be the SI unit? SI unit of work done is joule, charge is coulomb, so joules per coulomb. But again, we are honoring another physicist, that was Volt. I did not remember. I think Alexandra Volt. So for that, we are using the SI unit volt. So 1 volt is equals to, when 1 joule of work is done in bringing 1 coulomb of charge from infinity to that point. This is the potential, and potential difference from one point to another. And here put electric potential or potential, when 1 joule of work is done in bringing 1 coulomb of charge from infinity to a point, from infinity to any point, that will give you your electric potential, and potential difference from one point to another point. I hope that is super duper clear in your mind. The difference also, that also I have made it clear. Okay, another question for you. I'm giving you 2 minutes to solve it. Yeah, this I've told you. Yeah, so guys, I'm giving you 2 minutes to solve this question. Let me know in the chat box, what do you think the correct answer should be? What do you think? Let me know in the chat box after solving. 10 seconds more. Okay, so somebody has said B. Very good, it's the correct answer. B is definitely the correct answer. Very good, very good, very good. But how is it? Let me tell you that as well. Now I'm going to solve. Let's read the question. See, positive charge moves from point P to point Q. If the potential at P is 20 volt, potential at Q is likely to be what? 25 volt, 15 volt, 32 volt, or 90 volt. So here we are talking about the potential difference from one point to another point. Okay, let me change the orientation so that it can be visible to you. Yeah, so now they are asking us to find the potential at P. So we know that like you've read about two things, diffusion and osmosis, in your class 9th. But why am I telling you this, diffusion and osmosis? I'm telling you about diffusion and osmosis because in diffusion, you can say the gases or the substances move from a region of a higher concentration to the region of a lower concentration. So in the same manner, the charge is going to move from a region of, you can say, higher potential to a region of lower potential. Now by this I think the answer must have come to your minds. Okay. See, if it is going to move from P to Q, here at P the potential difference is 20 volt. So definitely if it is moving from a point, it should be lesser than that. This is basically talking about your logic. This is logical. So it cannot be 25 volt because it is greater than 20. It cannot be 32 volt because it is greater than 20, and it cannot be 90 volt. So the answer is 15 volt. This was too easy because it is lesser than 20. Is this concept clear? I hope it is. Now let's move ahead with the next question. Okay, a 10 volt battery is supplying current to a circuit. How much energy is supplied by the battery to each coulomb of electric charge passing through it? Options are 5 joule, 10 joule, 15 joule, or 20 joule. What do you think? Answers in the chat. What do you think? How much energy is required? Hello everyone. What are you all thinking? Okay, so now let me change the orientation so that I can explain you. Now pay attention over here. Now they are saying a 10 volt battery. So potential difference, we generally denote it with V. So that is given to you 10 volt. Okay. See how much energy is supplied. So energy in 9th class you read that in this context it will be equals to the work done. Okay, because if we are doing some work we need energy. Without energy we cannot do any work. Okay, so battery to each coulomb of electric charge. So each coulomb means 1 coulomb. So charge is given to you 1 coulomb. Now it's easy peasy. Now sorry, so now what do you want to find? You have to find the energy or the work done. So we know that V is equals to W upon Q, correct? Work done upon charge. So W will be equals to V into Q. Now it's super easy. So W will be equals to V is 10, Q is 1, 10 joule, khatam, finished. Okay, 1 minute, yeah. So 10 joule should be the correct answer for this particular question. So the work done is going to be 10 joule. And those of you who got it correct, give me a high five. That's really amazing. Okay, so now the session has come to an end, but although the tutorial has come to an end, but the Menti quiz is left. Your most awaited Menti quiz for this particular topic. And let me just tell you what we did today. Today we have done what is electric charge. Then what we understood what is the current. Then we talked about electric potential and then the potential difference. I hope that is clear, and I told you how are they connected, how electric potential and potential difference are connected to each other. So I hope now this is clear to you. This electric current potential difference concept is clear. In the next class we'll be doing Ohm's law, and I'll be teaching you resistance next Wednesday. Okay? Every Wednesday we'll be having our physics class for CBSE 10. So now are you ready for the Menti, everybody? Okay, I think there is a lot of Josh in the chat. Okay, so now I think we should begin with our Menti quiz. Let me go to the Menti and tell you the code. Where is it? What happened is my battery low. What happened to it? Yeah, just give me a minute. Is the live stream working or not? Yeah. I was just thinking that has it stopped or what? Fine, everyone. Take care. Now let me just present. So the code will be just coming. Yeah. So how to join the Menti? Go to www.menti.com and use the code 47092717. In this manner you can join Menti. Code I have already told you, it is 47092717. Quickly join the Menti, guys. Okay. Okay, one person has already joined. Actually, a call is there, so 1 second. Just pardon me, actually a call was there. So everybody quickly join the Menti. Let me reduce the size of my camera. What happened to it? Has Menti become Senti? Or I can just... What has happened? I'll just... What has exactly happened? Okay, so now let me go that side. Yeah. Now we are about to start. Only one person has joined. Quickly, everyone join the Menti. Oh my god, I think it is about to. What happened to it? What happened to my stream? Is it clear, everyone, or not? Only one person has joined. You have to reload. Okay, 1 second. I'm just reloading the Menti because I think my internet connection is slow. I think that today the internet connection is slow, so let's see if we can start. So now I'll be starting with it. Please be ready. Let's see if I can. Okay. Fine, I wouldn't wait for long. Let's get started. Okay, first question. What happened? Okay, fine. Now I am beginning the Menti. Quickly join everyone. Those of you who, which device is used to measure electric current? Okay. Ammeter, voltmeter, galvanometer, or both A and C. I did not tell you this during the Menti because I wanted to tell you over here. Wrong answer because I did not tell you, sorry. For your information, it is ammeter. Ammeter is a device which is used to measure the electric current. Okay? This is the device. Let's move ahead. So Mohan Kumar, big fan of you. Thank you so much. Okay, second question. Which I did not have the question or what? Okay, second question on your screen. Calculate work done when voltage is 5 volt and charge is 2 coulomb. 10 volt, 10 joules, 15 joules or 2.5 volt. What is the work done? This is a simple mathematical question. You just have to multiply both of them. What will be the answer? Very good. The answer is going to be 10 joule because we know that the SI unit of work done is joules. Okay? I hope the network is not slow because probably 1 second, let me just check. Okay. Fine. We are moving ahead to the next question. But before, let's check the leaderboard. Only one person is playing, so yes, it could have been correct, but just the thing is that current, electric current, coulombs per second means the same. So all of these is going to be your correct answer. Okay, do not get confused, please, from next time. I can understand this was a little bit tough, but that's okay. Let's check out. Okay, one person was only playing. Let's move ahead with the fourth question. And those of you who don't know how to join, you have to write www.menti.com on Google and use the code 47092714. Answer fast. What is the value of charge present in each electron? I told you. 1.6 is into 10 to the power 19, 1.6 into 10 to the power minus 19, 1.33 into 10 to the power 19, none of the above. Quickly. Yaar, I told you in the session only it is 1.6 into 10 to the power minus 19. We did the numerical. Really, it means you're not paying attention. Strange. Chalo. Let's move ahead. Last question, those of you who don't know how to join, I've told you that you have to go to www.menti.com and use the code 47092717. Last question, last opportunity for you to come on the leaderboard. Quickly, everyone. Is my stream going on? Yeah. I think I do not have much data left. Let's quickly have this question and then we'll end. Okay, last question for you, and the twist is we don't have options. What is the SI unit of charge and voltage? Quickly write down, you only have 10 seconds. SI unit of charge and voltage. Time's up. So the correct answer is coulomb and volt. And nobody could answer. The SI unit of charge is coulomb and the SI unit of voltage is volt. Voltage is the potential difference. Okay? Don't get confused, please. And also we measure voltage by an instrument known as voltmeter. And galvanometer is used to predict if there is an electric current or not. Okay? Okay. So the final leaderboard is here. What happened? So one person was only participating. Mohan Kumar has won today's match. Congratulations. Okay. So now we've reached at the end of the presentation. All right. So it's time to end today's session. I hope you've enjoyed today's session and you got to learn a lot of things. I have told you two important things about ammeter and voltmeter. Please note them down. Okay? Ammeter, voltmeter. That can be important for you. Do not forget. Okay? So now I'm signing off for today. We'll meet next Wednesday. Not for, you can say, really for all the classes. For class 9 tomorrow, we'll have the session at 12 p.m. Please attend 9 plus children. And for 10th physics, we'll be meeting next week. So bye-bye all of you. We'll meet soon. Until then, take care of yourselves. Bye-bye. Bye-bye, everybody.